Hello.
Hello. Hello, everyone. Hope all is well. Give me 1 second trying to connect this TV for everybody that's in this room. So give me 1 second. Okay, so that's not it either. That is good. It's not connected. So it's projected to the computer. Please connect HDMI cable to ensure device is exporting to video. All right, so while I figure this thing, I know last class we closed out chapter 5. And anybody have any questions or anything? Anybody trying to get stuck? Is everybody okay before we get into 6-1? Anybody have any questions or anything? How y'all doing? Y'all good?
My sister, my baby sister, apparently got into my notebook
Oh, no.
and had scissors cut it.
Oh, man.
I had to rewrite it.
How old are we talking?
She's 3.
Oh, nice.
I was like, oh, you're not telling me that. She had like big scissors, not like her baby scissors.
Uh-huh.
She had like real like scissors.
Oh, wow.
She's like, I practiced cutting now, sit down. So now whenever I'm in class, she has to like stay on line.
I mean, yeah.
But usually she just like sits on the floor whenever I'm in class.
Uh-huh.
I'm the one that has to watch her. My parents have work.
I'm sorry to hear about
I
that.
know, I was so upset. It took me all weekend. But I'm fine.
Okay, cool. So what I may have to do, I didn't bring any markers. So it seems like we are okay to move forward. Remember, every day still have opportunities to get with me and ask questions, whether it be through office hours, anything like that. So floor is always open to ask whatever questions you want to ask out of whatever section you're dealing with. So we'll go ahead and get started with 6-1. I'm going to scroll up a little so that those are on Zoom can copy. I'm going to, for you guys, see if I can get in contact with Charles and see why this TV is not working. I don't know if anybody want to look at this screen, but it's right here. I don't know if anybody like really helps. Y'all want to slide over here, and then I can get Charles to come in here. I either got to get a marker so I can write on this board, or we got to do that. So if y'all can give me a second. But we started with 6.1, verifying identities, trig identities. So you guys give me 1 second. Let me see if I can get a contact. Matter of fact. One second.
Oh, no, what's going on? Was just in here. I know this working. I ain't saying that. Oh, you got the wrong input, bro. Yeah, Chin, you got HDMI laptop. Oh, you trying to display your
Yeah, I'm trying to
laptop?
display this because it's connected to this one already.
Yeah.
And I was trying to shoot it up here.
And you got a
And it worked,
HDMI
it
connection.
worked
okay.
last week.
Oh, you got the video muted.
Vincent Tucker.
The video's muted.
Oh, so I need to put in the report?
Yeah,
See, put it in.
it's still put it.
Vincent Tucker, and
There you go.
I shall put in a report to have my class. My TV's not coming on. A105, building A105. I'll be send somebody as soon as possible. Appreciate it. Thank you. Oh, number is 757-477-5298. Need any more information? Thank you.
There you go. Appreciate you, bro.
Yeah.
But no, the video was just muted.
Okay.
This button right here.
Okay. I know. See,
No
that's why-
problem.
That's why you get paid the big bucks, man. Appreciate you, man.
No problem.
Yeah, for sure.
That's how.
Yeah, I know. I get it.
Whole process.
Yes, sir. That keeps you with a job. I get it. I said they keep the money rolling. I get it. Appreciate you. All right. So now we're rolling. Sorry, guys. Technology, if you don't know what you're doing, can be a hindrance versus a help. All right. So we're looking at verifying trig identities. We have our fundamental. I could write that a little better. Fundamental trig identities. Now, some of these you've already seen. They're relating to the relationship between sine and cosecant, cosecant and secant, and then tan and cotangent. So these are our reciprocal identities. All right. I'm guessing you copied a few of the top ones. If not, let me know. All right, then we have our quotient identities. So tangent is sine over cosine, cotangent is cosine over sine. Talked about these relationships already as well, but just re-emphasizing. All right, scrolling up some. We also have our Pythagorean identities. Sine squared x plus cosine squared is equal to 1. 1 plus tan squared is equal to secant squared. 1 plus cotangent squared is equal to cosecant squared. Always find a way to show up and pop up, especially this one right here is secant squared plus, I said secant, sine squared plus cosine squared is equal to 1. That one shows up the most. So even if you don't remember the other two, most definitely you want to hold on to the fact that sine squared plus cosine squared is equal to 1. All right, scrolling up. You have even identities, what we call even identities and odd identities. Cosine and secant are the only ones that are even. So when you plug in negative x, when you apply cosine to it, it's the same thing as positive cosine x. Same thing with secant. The other 4 are considered odd identities. If I scroll it too far, let me know. So sine of negative x is the same thing as negative sine x. Sine, and then tan of negative x is the same thing as negative tan x. And so same thing with cosecant and cotangent. All right, everybody good? So we're going to use all of these relationships to verify identities. In other words, they're not asking you, well, I'll say it like this, I want to say that. We're going to verify the identity. We want to say that one side is equal to the other. We want to prove that one side is equal to the other. In other words, that this statement is a true statement. So the first one we're looking at is secant x times cotangent x equal to cosecant x. So we want to prove that this is true. All right. I think I want to make that a color. Let's go purple. All right, so we have a few hints as to what your mindset should be when you go about trying to verify these identities. So the first one is convert each to cosine and sine. Now, when you go about doing these, sometimes these will help. If not, you go on to the next thing. But you convert to each to cosine and sine. Next one, work with one side at a time. So you don't want to get ahead of yourself. You don't want to do too much at one time. Want to break one side down as much as possible, then break down the other side. Then the third one, try to work the more complicated side down to the less complex side. So when you look at what we have up here, we would try working on this left side and try to break it down to just one single trig function, which is cosecant. All right. So like I mentioned, we're going to work this left side and try to break it down as much as possible. First thing we're going to do is convert both to sine and cosine. So that's what I did there. Secant x times cotangent x. I took secant x and converted that to 1 over cosine. And then cotangent is cosine over sine. All right. So we see now from here is not trig. What we're going to do is algebra. Cosine over cosine will cancel. That's algebraic. And that'll leave us with just 1 over sine. And then we recognize our trig relationship that 1 over sine is the same thing as cosecant. And so we just proved it. Oh, we got that. Oh, well, you know what? That. And remember, that's what we're trying to prove, cosecant. And the left side is equal to the right side in cosecant. Any problems, any questions before we look at the next one? Anybody? All right, let's try it again. Here we have 1 plus sine over cosine. So this is our original right here. I said that's our original. I didn't mean it like that. The whole thing is our original. That's why. And we want to prove that this left side is equal to this right side. All right. So when I look at this type of problem, you see I have one whole fraction here, but then here I have two separate terms. So what I would do is try to break this up, if possible, into these two separate terms. And the one way we can do that is by looking at this cosine and recognize that it can go into both. Whenever you have a numerator that has multiple terms, you know, the plus and minus sign separate your terms. The denominator has to go into each term in that numerator. So that will break up to give us 1 over cosine plus sine over cosine. Cosine is secant. And then 1 over, I'm not 1 over, but sine over cosine is tangent. And that gives us our left side. Make sure we're all right. Questions, any questions? Scroll up, everybody good? All right, so 6-1, that's what the 6-1 is. It's just taking these trig equations, these trig identities, and proving the expression that they give to you. So this one, sine tan plus cosine is equal to secant. So once again, we're going to look to work this left side because the left side is more complex than what's going on in the right side. All right, so I'm going to rewrite those as cosine and sine. So sine, of course, is just sine, but tangent is sine over cosine. And cosine is just sine as well. I mean, cosine is just cosine as well. Now, if I were to multiply this over here, that's just going to be sine squared over cosine. Now, don't forget what we're trying to prove. On this right side, we have a single term of secant. So it would be in my best interest to try to combine these two fractions here to see if it will simplify down to secant. And so in order for you to add fractions, don't forget you have to have a common denominator. So my denominator here is cosine, my denominator here is 1. So I need to multiply top and bottom here by cosine so that I can have a term that has cosine in the denominator. And so that takes us here, sine squared x over cosine x plus cosine squared x over cosine. Some of these things, these relationships, you know, it'll get easier the more you do it. I'll say it like that. Some things aren't going to come to you in some vision that you will have as to where to go and how to go. It may not come to you till you make mistakes. You'll get to a point where you're like, this doesn't prove anything. Then you have to double back and redo things. Some stuff is just trial and error. The more you do it, the more you get comfortable with it, the more you'll foresee certain things. You'll be like, you know what, that's not going to work before you start writing. But it's not going to come with practice. You know, so it's only going to come with practice. So just like when I was doing this, I had already saw that I was going to have this situation, sine squared plus cosine squared. So remember, that's your Pythagorean identity. Remember I told you that's one of the main ones that will show up regularly, that's sine squared plus cosine squared. So remember, whenever you have your common denominators, or once you have your common denominators, you can just add your numerators together. And that's what we had here, sine squared plus cosine squared. And that Pythagorean identity reduces down to just 1. So that gives us 1 over cosine. And 1 over cosine is secant. And that's what we were trying to prove. Nah, go back. All right. Questions before we do another one? Make sure we're all right. All right. So the next one, we have sine. Cosine, sine minus sine, cosine squared equal to sine cubed. So sine x. So I can get this to where I want it. All right. So you see what I said? The first thing that would be good for us to do here is to factor out sine. Reason being, we can't add them together. Excuse me. All right. So we can't add them or subtract them from each other or anything like that. They're not fractions involved. So the next move is to, like I said, apply your algebraic principles in which I can factor out sine. And so that leads me here. Sine x, then times 1 minus cosine squared x. Now notice over here in purple, 1 minus cosine squared. If you use your Pythagorean identity, once again, we're talking about the one that's sine squared plus cosine squared equal to 1. If I were to subtract cosine squared from both sides, sine squared is equal to 1 minus cosine squared. So all we did was take the Pythagorean identity and manipulate it by subtracting cosine squared from both sides. And so now we see that 1 minus cosine squared is equal to sine squared. I think here I was just rewriting. I think somebody asked me a question about the same thing. So I was just rewriting or explaining it a different way. But yeah, you can always manipulate those Pythagorean identities in order to fit what's going on in the problem. So and so now that we see that 1 minus cosine squared is equal to sine squared, sine times sine squared is sine cubed. And that's what we were looking for. All right. Questions on that? Make sure we're okay. Why anything happened? Is everybody all right? Before we look at another one. Like I said, this section, that's all the section is, just verifying identities, using those foundational relationships and proving that the left side is equal to the right side. All right. So here we have cosine x over 1 plus sine x plus 1 plus sine x over cosine x equal to 2 secant x. So once again, we are looking at this left side and simplifying it or bringing it together, combining it so that it can be one single term, which is 2 secant x. Now we have fractions. Since that's the case, we have to have an LCD, and you see already established that. This is 1 plus sine times cosine. So it's just a combination of both denominators that are in the problem. So if that's the case, going to multiply top and bottom by cosine in this first one. Then in the next one, multiplying top and bottom by 1 plus sine x. So then we're going to simplify this as much as possible as far as our numerators are concerned. Take note that I'm not going to mess with these denominators. I'm going to leave those the way they are. Not going to distribute those. Here, cosine and cosine will be cosine squared. And then here we'll do our foiling out. 1 times 1 is 1. 1 times sine is sine. Sine times 1 is sine. Sine times sine is sine squared. So that's what we have right here. All right, everybody good? Okay, so now let's look at simplifying this. Oh, sine and sine, that's just 2 sine, adding together, adding like terms. But also notice we have this relationship that I kept telling you is going to keep showing up. We have cosine squared and sine squared added together. So I just move my terms just to have a visual. I brought them together, cosine squared plus sine squared. And notice, like I said, right here, sine and sine gives us 2 sine. So cosine squared plus sine squared is equal to 1. We still have 1 as a part of our problem, so it should be a second 1 there. So make sure you don't lose ones and lose terms. You know, be careful with that. And then we see we still have 2 sine x. So we have 1 plus 1 plus 2 sine x. So 1 plus 1 is 2. So now we have 2 plus 2 sine x. Factor out the 2. That's 2 times 1 plus sine x. And now we can cancel out 1 plus sine x. That gives me 2 over cosine. Just recognizing that 2 over cosine can be rewritten as 1. I mean, it's 2 times 1 over cosine. And that 1 over cosine is secant. So now we have 2 secant x. Remember, that's what we were looking for up here. All right. Questions? Any questions? Straight. All right, in the chat, Zoom. All right. Let's do another one. We have tan minus sine of negative x over 1 plus cosine x equal to tan x. All right, so I put the note up here that sine is an odd identity. So that means that sine of negative x is the same thing as negative sine x. And then notice that puts us in a position of having a negative to a negative, which turns positive. So we now have tan x plus sine x over 1 plus cosine x. All right, so what I decided to do here was bring that numerator together. Remember, one of our tactics is to, if you don't see anywhere else to go with something, and that's what we're looking at right here. I have tan plus sine over 1 plus cosine. It's really not many places I can go with that, but I do know I can rewrite tan in terms of sine and cosine. So that's always an option. Now remember, like I mentioned before, just because you try something doesn't mean it's going to work. And just because you did something legitimately, like there's nothing wrong with doing this. But you know, you try stuff out and see if it's going to work. And then the more you try things, the more you see what will work and what will not work. So if I convert that tangent to sine over cosine, and then I look at sine as being a fraction of sine over 1, I need 2 in order to be able to combine them, have common denominators once again. And that means I need to multiply top and bottom by cosine here. So this is what we're looking at. Sine x over cosine x plus sine cosine over cosine. And that's all still over 1 plus cosine. Okay, so let's bring them together. We have sine plus sine cosine over cosine, all over 1 plus cosine. Notice we have sine that exists in both terms. So we'll be able to factor that out. I'll probably do that in the next, yeah, I do that. But yep, so we have sine, I'm gonna do it in the next step. I thought I underlined it there, I thought I did it next step. But what I did decide to do was to rewrite this. You know, this is considered written vertically. So I'm gonna rewrite my division as horizontal. And so that division sign right here, this division bar is the same thing as this division sign. How's it going, sir? Thank you, sir. Same to you. And so then whenever you divide by a fraction, you multiply by the reciprocal. So we got this division sign, it changes to multiplication. And then I flip this. That's why I have 1 over 1 plus cosine. All right, so now let's go ahead and factor out that sign from both terms. And that'll be sine times 1 plus cosine over cosine times 1 over 1 plus cosine. So now the 1 plus cosine, the quantity of 1 plus cosine will cancel out in the top and bottom, leave me with sine over cosine, which is just tangent. Any questions? Any questions? Make sure we're all right. Some questions may not show up until you actually start working this stuff on, working it out, trying to figure it out. So that's understandable as well. See, I have another one. Yep, I got another one down here. I think this is the last one. Yep. Okay. So let me, somebody say something. But it's fun puzzles. Somebody said in the chat looks like a puzzle. This is fun puzzle. All right, so let me erase some of the scribbles. So, all right. Okay, yeah, I might as well leave that there. Okay, so we have these, have this equation, but we have these two quantities, these two expressions, cosine theta minus sine theta squared plus cosine theta plus sine theta squared equal to 2. So you want to prove that this left side, all of this left side is equal to just 2. The only way we can go about doing that is go ahead and foiling out each piece. So notice the first one I have in red. And then that second one, I've expanded it out in purple. Give you a chance to write that red one down first. So we have cosine minus cosine minus sine times cosine minus sine. So whenever you have that square in your quantity, don't forget you can't just square the cosine, square the sine, and have cosine squared minus sine squared. You actually have to expand it and foil it out the way we did right here. So when you do that, that'll be cosine squared minus cosine sine minus cosine sine plus sine squared. And then you notice in the middle, those are like terms. So negative cosine sine minus cosine sine will be negative 2 cosine sine with your cosine squared and your sine squared on the outside of that. All right. And then we do the same thing for the second set. Like I said, I put that one in purple. Just expand it out and multiply. Combine your like terms in the middle. Give us pretty much the same expression, except we have a positive 2 cosine sine instead of a negative 2 cosine sine. Mm-hmm. So we're going to add both of those together. Combine all of our like terms. And in the order you do it, and the order you do your simplification and apply your trig functions is up to you. Trig identities, up to you. But ultimately, you still should get the same answer. Still should reduce down to 2. So what I decided to do is to go ahead and just combine all my like terms. Cosine squared plus cosine squared gives me 2 cosine squared. My negative 2 cosine sine and positive 2 cosine sine cancels. Then I have sine squared plus sine squared gives me 2 sine squared. Pulling out the 2, that leaves me with cosine squared plus sine squared. Once again, it showed up again at Pythagorean identity. So that 2 times 1 would just be 2. Mhm. Questions. Mhm. Everybody good before I start talking about something else? Make sure you're all right. Everybody on straight. All right. So that's it for 6-1. So like I said, that's what 6-1 entails. When we go into 6-2, same type of stuff, but they introduce some new things, sum of difference formula, and we'll be using that. And we also can use that to verify identities as well. But we'll save that for next class. Don't want to throw too much at you at one time. Also notice that, chapter 6 is just 4 sections, 6-1, 6-2, 3, and 5. I think I did confirm that. I thought I had looked it up. Oh, you know what? I think it was in my other class. But yeah, I mean, I'm other class, my computer. But yeah, 6-1, 6-2, 6-3, and 6-5 should be our sections for chapter 6. 60 double angle. Shouldn't be going to 6-4, right? So yep. All right. So before we close out today, any questions? Everybody good? Everybody straight? Someone said something in the chat. Yes, we'll skip 6-4. 6-4 is not a requirement for this course. Yeah. Mhm. Is due by it. So in other words, so for those in the Zoom, we have a question about a due date and your test, and pretty much all of your content for chapter 5 is due by the 17th. So that means you can do it before then. You don't have to wait until then to do it, because sometimes people think that I say you got to take it on the 17th. So you don't have to take it on the 17th. You can, but at 11:59, rolling into the next day, it will cut you off once 12 o'clock midnight. Yeah. No, you're fine. You're fine. It's a good clarification. Good question. All right, somebody else. Yes, chapter 5 test should be up there. I can confirm real quick before you guys leave.
It's in Pearson for me. Yeah.
Yes, it should be a math lab, right? You say you see it in
You
math
need
lab?
our scratch paper.
Yes. Your scratch paper for your test, not your homework. So just want to make sure everybody else is clear. I know you weren't asking that. Want to make sure everybody else is clear on that. So I don't need scratch work for your homework, but you scratch work for your test is what I will be looking for. So 6-4, no, 6-4 will not be on the test since I don't have a homework for it. I'm not going to do a lecture on it. So it's not anything that you have to be concerned about. All right. Anything else? Anybody else? Everybody good? Okay. So if you guys are good, I'm good. Thank you for your patience with the TV and stuff.
Fine.
Those in here. All right. Take care, sir. Take care, everybody. Y'all have a good week, and I will see you next class.
Have a
All
good one.
right.
Yeah, have a good
Thank
one.
you.
All right, y'all. Yeah, sorry about the TV thing again, y'all. All right.